Let's solve this problem involving Gibbs free energy and equilibrium constants. We have a reaction where enzyme A in aqueous solution forms B in aqueous solution. We're given that the standard Gibbs free energy, delta G naught, is negative 6.010 kilojoules per mole. We need to find the equilibrium constant at 25 degrees Celsius, and then calculate delta G at body temperature, 37 degrees Celsius. Let's start with finding the equilibrium constant. We can use the relationship between delta G naught and K equilibrium. Delta G naught equals negative our TLN of K equilibrium. Rearranging this to solve for K equilibrium, we get K equilibrium equals e to the negative delta G naught over RT. Now let's plug in our values. R is 8.314 joules per mole Kelvin, T is 298 Kelvin, and delta G naught is negative 6,010 joules per mole. When we calculate this, we get K equilibrium equals 11.31. For the second part, we need to find delta G at body temperature. The equation for delta G is delta G equals delta G naught plus our TLN of the quotient of concentrations of products over reactants. We're given that the concentration of A is 1.9 molar and B is 0.55 molar. Let's plug everything into our equation. We have negative 6,010 joules per mole plus 8.314 joules per mole Kelvin times 310 Kelvin times the natural log of 0.55 over 1.9. When we calculate this out, we get 3,195 joules per mole, or 3.195 kilojoules per mole. Let's understand what this means physically. Since delta G is positive at these conditions, the reaction is non-spontaneous in the forward direction. This makes sense because our reaction quotient of 0.289 is much smaller than our equilibrium constant of 11.31, meaning the reaction will tend to produce more products to reach equilibrium.